I sit here, right?
Ah, yes, no problem.
Oh, here.
ちょっとやってください。わかんない。どこだっけ。これが使えるの。すみません。字が見えません。小さくて。
今左上にある。
大きくなるのこれ。
一番上です。一番上。
これ字が大きくならないですか。
Oh, to some more here.
見えない。
あ、
いや、もし私が操作するんだけど、拡大してもらった方がいいけど。
あ、そうですか。拡大の仕方、私も。表示。拡大アイコンとかにさ。
アイコンじゃないんだ。まあこっちの方がいいか。
はい。
これですね。ボリューム上げるの。
My name is Kazuya Suzuki, Chief Representative of JICA Thailand office. I'm sorry that I cannot be with you today in person.
Hello.
smart
Files that went away. Do you know where it is?
why the set is very small tab
Sorry, I can see. That's too small. わかんない。
わからないいやわからないah come
Yeah, we need other presentations.
no no we can share from there
I think we have presentation will start from here, except for this video.
really
Here, yeah, that's my understanding.
really แชร์ยังวะ ขึ้นกันนี่ไง from here เอาไง not yet
これは
presentation
でもこれがなかなか、これは
here okay
これ早く映さないとこれ。
okay
これが映んないと始まらないよ。
Still would not see on the screen.
Yeah, that's the issue.
They have to switch the screen to
I think so.
อืมอืมอืมอืมอืม
ไม่มาให้
ไม่มาต่อยังนั้นเนี่ยเหมือนไม่ได้ต่อเลยต่อแล้วนี่อืมอืม
เสียบแล้วนะ
เก็บแล้วครับโอเค
มันมีเบ้าคุมตรงนั้นหรือเปล่าว่าสวิตช์ให้ใช้สายจากฝั่งนู้นหรือฝั่งเรา
แป๊บหนึ่งครับเดี๋ยวลองดูครับอืมอืม
Nothing happens.
ต้นคุณมันไม่แชร์เข้าไปอ่ะนิดหน่อยดิ coming 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 มายัง
さっき試した。Why?
ยังไม่มาเลยครับต้นเลยอืมอืมอืมอืมใช่ไหม yes come on come on come on จอยังไม่มาเลย
มาแล้วมาแล้ว
มาแล้วครับ อุ้ยเอ้ยไม่ใช่
ビデオですね。
วิดีโออะครับ แต่ว่าสไลด์ยังไม่มาเลย จากเครื่องนี้หรือว่าใช้เครื่องนี้หรือเครื่องนู้น โอเคครับเดี๋ยวพี่เช็คสไลด์เครื่องนี้อีกทีครับหนึ่งนะ
これ出ない。そう、これ映んないんですか？結局。
ちょっと待って
ちょっと待って。
うんテスト今
違いです。
yes เดี๋ยวครับยังไม่มาเลยขอเทสอันนี้แป๊บ
それはあっちで切り替えるので、はい、今はあっちのこっちに投影してるので、ビデオが終わったらこれを投影する。
これを最初に出したいんだっていうやつです。
ああ、
うん
それは難しいですね。
うん โอเค
まあちょっと終わったら。
พร้อมหรือยังผมเริ่ม
Professor
ได้ไหม
Charamchom.
Okay. Good afternoon, everyone, and welcome to the Thailand-Japan special session today. My name is Chalermchon Sathirapot. I'm a professor at the Department of Survey Engineering, Chulalongkorn University, and I have my co-chair, Mr. Chinnatat from GISTA, as well as some of the speakers along with me today. From our session, we will begin with the welcome speech by the Suzuki-san, Chief Officer of Thailand JICA Office. by he already sent us the video to address his speech. Later on, there will be a presentation on site. Yeah. Please.
Sawadee Krap, Professor Charam Chom, distinguished guests, ladies and gentlemen. Good afternoon, Sawadee Krap. My name is Kazuya Suzuki, Chief Representative of JICA Thailand office. I'm sorry that I cannot be with you today in person, so please excuse me for delivering my message from Bangkok. On behalf of JICA, I'd like to extend my heartfelt greetings and welcome all of you to this special session, which is jointly organized by our Thai and Japanese partners, who have been working hard as one team for more than 3 years to achieve success for the JICA Technical Cooperation Project for capacity development and promotion of utilization of National Codes Data Center, or the TIGAS project. This coming February will mark the completion of this 3 years and a half cooperation project. And I am delighted to learn that the project has, to a highly satisfactory level, achieved its purpose of capacity development for operation and maintenance of the National Codes Data Center, or NCDC, as well as promotion of data utilization in various fields. For JICA, this project has demonstrated one of the outstanding collaboration efforts between Thailand and Japan, not only among the government counterpart agencies who have their core stations integrated, but also those from the private sector who actively participated in the pilot project to verify the reliability of the data distributed by NCDC. Although the project will soon be completed, we hope to share our expertise, our experience, and lessons learned from Thailand with our partners in other countries in Asia, where we are supporting the development and utilization of codes as well. Finally, I'd like to take this opportunity to express my deepest gratitude to all the valuable stakeholders for your dedication and contribution, especially Professor Charam Chong, for your excellent leadership of the Thai-Japan Joint Working Group throughout the project period. Kopumaka. I sincerely hope that this one team spirit will be seamlessly maintained so that the project's goal will be achieved in the near future and contribute to the realization of Thailand 4.0. I also thank the MGA Secretariat for providing us the opportunity to make this Thailand-Japan special session as an invaluable platform to share the current status of NCDC, the achievements of the TIGAS project, and our vision for future initiatives related to Japan's cooperation in the GNSS field. It is my hope that this platform will contribute to a broader understanding and increased utilization of NCDC, fostering continued collaboration on GNSS in Asia, including Japan and Thailand. Kopumaka, thank you very much for your attention.
Thank you very much, Suzuki-san, for your kind message. And now let's move to the next presentation. The first presentation will be about an overview of the and achievement of the Tiger projects, which will be presented by Dr. Suji, the JICA team leaders from Japan side. Please.
Okay. Okay, thank you very much. I'm Suji of Pasco Corporation, representing the JICA project team today. Let me brief the JICA project on COAS in Thailand. This is the project for capacity development and promotion of utilization of National COAS Data Center, but we call it TIGERS for short, wishing to tie. Okay, sorry. Okay, so now wishing to tie GNS cores tie GNS cores in Thailand, TIGERS project. Okay, now let me go from the background. As you know, COAS is next page, please. As you know, COAS is a continuously operating reference stations and for GNS satellites. And in case of Japan, Geospatial Information Authority has been operating one of the largest COAS in the world for more than 25 years, contributing to their society as infrastructure for surveying and mapping, cluster deformation monitoring, precise real-time positioning, including the ICT construction and precise farming, and also to the weather forecast in Japan. Like Japan, Thailand has established many COAS already, as shown in this map, but as the color indicates, they are developed by different agencies for all their own purposes. For example, DOL for the cadastral surveys, LTSD for mapping and geodetic surveys, for GPT, engineering surveys, and HII, universities, and GISTA for research purposes. So therefore, Thailand government decided to establish National COAS Data Center for providing the national service with integrated coordinates. And JICA has been supporting NCDC since 2021. NCDC collects real-time GNS data from the data in Thailand and calculates and provide correction data to users, enabling real-time precision of 2 to 3 centimeters. This project is purely technical in a sense that Japan does not provide any COAS, but we provide knowledge and experiences learned from many years of operation and promotion in COAS in Japan. We have two outputs. One is the operation of NCDC, and the other read by LTSD, and the other is the promotion of NCDC led by GISTA, both with close collaboration from DOL, DPT, and HII. By spiraling up these two activities, we aim to develop capacity for NCDC operation and maintenance and to promote NCDC's utilization in various fields at the end of the project, which happens to be the end of next month. We believe this will lead to the business development and innovation in the near future, contributing to the realization of Thailand 4.0, which is the dream of Professor Chon Sensei, a respectful advisor from Chile University. Now, let me go on to each output. The first one is NCDC operation. To share Japan's experience on COAS operation, Output 1 team had 34 online meetings and 64 online sessions in 3 years. We focused on creating and updating the NCDC operation manuals, lectures on best practices and something new, monitoring of NCDC equality and delay. We made a step-by-step improvement based on feedback from users, introduced a monitoring method named Deemed Rover, where we use COAS as a rover to see precision and delay of correction data. Quite recently, we found ionospheric disturbances, known as plasma bubble, seems to degrade positioning results at night in Thailand, so monitoring would be much more important. So these are some snapshots showing how we worked together, both online and on site, for the field work, data delay discussion, software tuning, and radio interference detection near the cores. So thanks to hard works of LTSD and other agencies, NCDC portal has been open for public service since March 2022, providing precise positioning service with the unified coordinates based on ITRF 2014, currently free of charge. So you can see the logos of related agencies, including JICA, in this portal. The number of registered users has been increasing to over 2,000, and data availability is around 95 to 98 now. Good numbers, I think. Now let's look at another important output, NCDC promotion. In addition to 30 monthly meetings for all project members, Output 2 team had 41 online sessions so far in 3 years for the promotion with the CDC. The team organized public relations tools such as Reflect and use case webpage shown here. Also organized pilot projects in survey, agriculture, and construction, as well as many seminars, trainings, workshops, and site tours. The pilot projects are the integral part of the NCDC promotion. Private companies from Japan and Thailand conducted 8 pilot projects using NCDC data in the fields of surveys, construction, agriculture, and autonomous vehicle driving. They are implemented by Topcom, Biomat Inc., Yammer Agri, Nishio Rental, Kantan Motors, Siam Yamaha, and Asia Technology Industry, and the results will be presented later today by video. We really appreciate their comments and feedback to NCDC, which are very helpful to improve NCDC service. These are, again, the snapshots of the, a snapshot of the promotional activities. In conclusion, over 900 people participated in these events, and more than 20,000 people visited the NCDC website. Again, the pictures of the agricultural demonstration. And also we had some lectures at the universities, and also some economic driving meeting with government officials. So we continue this kind of promotion. What is interesting is the regional workshop in last September. JICA and Thai team invited government officials from 6 countries in Asia to Bangkok to share experiences in Tiger's project, as well as to exchange ideas regarding COAS. Since we found that we have so many common issues on COAS operation and utilization, we are determined to continue this kind of follow-up information exchange. And I'm happy to report that this Monday, we just had the first union online with 8 countries, including Japan. So we will continue this kind of regional activity in every 6 months. That's current plan. And also, we also have another project finance seminar and user meeting. In the user meeting, we had a very candid discussion. So as you can see in the picture, pilot users are asking many questions to providers from 5 agencies. So that was a very good discussion. Okay, that was how we proceeded. Now, let me focus on the achievements and challenges. As reviewed today, many activities are done for 2 outputs, but we need some objective values to judge whether the project is successful or not. One indicator for the output 1, stable operation, is number of inquiries from NCT users. As you can see, in the first stage, we have few inquiries from users, but now we accept more than 10 interactions to users, so that's a good sign. And NCT staff is, and almost not complaints. So we can say NCT staff is doing good work to operate NCDC. Another indicator is the monthly average calculation rate of COAS data, Linux data, and the targeted value is more than 95%. And well, sometimes we had some problems like the overhaul of NCT server, so we have some sudden drop around here in May 23rd. But currently, as you can see, the rate is increasing, and I think output 1 activities has been achieved properly. Next indicator is the verification number of registered users for output 2. Thanks to many activities of output 2 groups, the awareness of NCDC was improved, and the number of registered users as of December 23 had doubled to 2,000 in 1.5 years. So by the completion of two outputs, we can say we have achieved the project purpose of capacity development of NCD's operational maintenance and promotion of its utilization in various fields. However, to achieve the overall goal of utilization of NCDC in public and private sectors and business development and innovation in the next 3 years, there are some issues to be tackled after the project. We have some challenges. We found that the precision of GNSS degrades when equatorial plasma bubble is over Thailand. So we are expecting the next solar maximum in 2025. So monitoring of this kind of ionosphere is very important. And due to the hardware limitations, NCDC is currently not using all course data in Thailand. We have more than 300, but we are handling a part of it. So maybe we need the update of the NCDC in future by Thai budget. And third, establishment of certification system for GN survey equipment is desirable, which will be talked from new colleagues. And also, that last one is we should have more users. Promotion to potential users is probably a never-ending process. Okay. So in any case, and actually, based on these challenges, I understand Thai side is now requesting Japanese government about the extension or second phase of this project. And that's under consideration, and I hope that will be accepted by Japan. In any case, I believe this project is quite successful in establishing the one team aiming to continue to making Thailand better and happier through NCDC. I would like to thank all the people involved in this project, especially Professor Chon Sensei for his warm and gentle guidance, officers of 5 agencies for their hard works, so to operate and promote NCDC, and last but not least, pilot project users for testing NCDC and giving us valuable feedbacks. Yes, we are one team. Thank you.
Thank you very much, Suji-san, for an overview and a summary of achievements through the Tiger project phase 1. I would emphasize it's phase 1 because we already submit our proposal for the phase 2 of Tiger projects, and it's now under the consideration of Japanese government, and we hope to hear the good news soon. And in any case, if any other country would like to do the same thing with us, we are very much happy to share our knowledge and also experience through this. Next, I would like to ask Colonel Dr. Sompot, a representative from Royal Thai Survey Department, one of the main agency involved in Tiger project, to give an introduction of what we call NCDC or National Core Data Center. Please, the floor is yours.
Thank you, Professor Chon. Can you hear me? 1, 2, 3, 4, 5. Good morning. No. This is a palm time for everyone. I know that. Let me try to brief as short as I can do for NCDC. Okay, maybe almost contract. Suji-san present already. I just emphasize some NCDC character. No one know. Anybody don't know about core? I think I saw some. Sorry. Okay, I come back. I think anybody don't know about core? No, okay. This is a core, continuously operation reference station. It's for what? For what's called precision, accuracy, right? Improvements. They have 4 functions already, no more that. Or you have 5, just call me. One is antenna, receive the signal, and receiver for process, and then communication to feed the data. And last one, without that, not working at all, power. This is 4 function. Right now, okay. Before we have NCDC, we have our own. I'm from RTSD. We have 80 core, 2 type, standalone and on the roof, and we have center to control that. And also, at the same time, several organizations or the core also Chulalongkorn University, Department of Land, Department of what DPT, Town Planning, something like that. Sorry, SII and GISDA. Everyone have, but they work for the individual mission. After that, the government by National Geoinformatics Board approve give us homework assignments to establish National Core Data Center 3 years ago, and for us to integrate all core station to Thailand to harmonize to be the same. This is a quite unique character of core network around the world. We call not ad hoc. We have task force. It means align together to serve better for core. And then now we indicate 230 stations together with baseline among the core station is 30 to 80 kilometers. It's cover all Thailand. And let's back to how to work. We have NGB, National Informatics Board for priority at the government level, and then we have one subcommittee we call subcommittee on management of GNSS structure to control us again, and 5 alliance work together: RTSD, DOL, SII, GISDA, and DPT. Our NCDC center is located at Rat Phao Center of Bangkok. This is the systematic of NCCC working. They have 3 main components, right? Feeds the data from our 5 alliance to the center, and then the center feed back to the user. This is the data center. We have 2 software. One is Leica Spider, is for management for 256 station, and we have Multi-GNSS for positioning calculation, very precise. And for network design, we try to design the distance between core around 20 kilometers, idealistic. And also, another thing is, if you calculate for whole 250 station is overload. We have to make to small cluster, small group, like show you on the right hand side, to to save the energy. Sorry. Boop. Okay. And then this is our website. Now we provide you the service free of charge. Please feel free to access and apply that on the website above. And our service consists of 3 kinds of service: network RTK, Linux data download, and online processing. This is network RTK. We provide 5 VRS, KP, FKP, Mac, iMac, and single bed. And this is Linux download. You can download and process your data by yourself, or you don't want to process by yourself, you can upload your observation data to our website and get the result by online processing. And let Sichi-san mentioned already, we have key performance. Even the project finished, but we continue to do KPI by ourselves. Data acquisition of rate of Linux at NCDC now is 95% above or lower a bit, but not different like this. And we have a deem lower analysis to check our quality of service. This is we get cooperation with Japanese counterpart to do it. And from this one, we can see many things, many problems to tackle to improve our service. Among agencies, use NCC for their own mission. Like for us, it's for military, for agriculture, for hydrologic management, or foreign show you in the slide. And also, not only for survey, but we try to promote for business that related with GNSS signal. Like, we will show in the detail in next presentation. 8 pilot project have been conducted and successfully, and also some of business now we can say they can in the state phase, they can start going. Like this, we conduct the agriculture day. This is a main what's called main industry in Thailand is agriculture. We invite many stakeholders, and this event is quite successful. Many potential user access and to use NDCC for agriculture purpose to increase their productivity. And also several media pay attention for this event. This is media from Japan make a scoop, very informative scoop to tell about NDCC. Okay. And for to the number of register, it is after we join with a Thai Ghost project, the number increased gradually. Let's say 100 users per month, and never stop and grow like this stably, not sharply like that. It sharply maybe down rapidly also. We hope we go like this continuously for year to year after this. And we found a challenge also. For example, from result of dim lower analysis, we found something like the fig rate is not going well. And then we just check, okay, we can see the problem like communication part. Now we try to fix, and some we fix already. And like this, it's not continue like this. From this technique, we can see many things after we read this graph. Like this is like internet down, something like that, and down again and again. And also, like Suji-san mentioned about what's called atmospheric effect. Now what we have already is swing like this. This is will be more serious in next year. I think next year. This is why we have to cooperation with our counterpart to solve this. I think not only Thailand, globally face the same problem. Like this, you see, if plasma bubble occur, the signal gone. And also, we have even we have the excellent or best core network, but if the user didn't have low cost receiver, impossible to improve or implement more industry. We have tried to try to recommend our sponsor to don't try only feed only technical experience, but try to find a way to to access cheap or not cheap low cost receiver for user in Thailand and another region also. Okay, for move forward, Tiger 1 is achieved already. Acquisition rate is 95%. It's now suitable for surveying and intelligent agriculture and new related business start and go. Move forward. Now we try to sustain and credit of NDCC why we have to cooperate with JICA again. For this one, hit 100% or nearly 100% for acquisition rates. This is a GSI standard for more advanced industry like UAV or autonomous vehicle. And more serious, that I mentioned you solar activity. This is why we have to tackle together with our counterparts. And another thing is we have receiver, but how can we creditable that receiver? We have to make check the quality of receiver also. Thank you for all.
Thank you, Colonel Dr. Sompot, for the introduction of NCDC and its performance. Next, I would like to ask my co-chair to give some introduction for the next speaker, please.
Thank you, Dr. Chalermchon, and thank you, Dr. Sompot, for your presentation. Next, I would like to introduce you the representative of the National Institute of Meteorology of Thailand, with her the one and only expert in her really unique and important work in Thailand. Please welcome Dr. Dr. Thiyatip Thongtan.
Thank you very much, co-chair, for a nice introduction. So thanks for the MGA host for allowing me to present my work on GNSS measurement, especially on timing and our testing and facilities at National Institute of Meteorology, Thailand. So my outline, I would like to introduce our national positioning and timing infrastructure, and I would like to tell you our plan on national quality infrastructure, especially on standardization on GNSS receiver calibration, as Colonel Sompot has mentioned in his last slide, as well as our measurement labs on geodetic measurements apart from timing aspect. So our national positioning and timing infrastructure, you have seen all the positionings and infrastructure as well as services that was provided by the collaborated NCDC. So we also part of them as the only timing station where we have connect our clock to the international time scale, and it was reported by the BIPM of the time differences between coordinated universal time and the time determined at our institute, UTC NIMT. And at the moment, we provide timing services apart from NCDC, real-time correction, or the receiver timing offsets. We provide calibration services and the internet service by the NTP or precise timing protocol, as well as now we are working on the research on the future generation of atomic clock using ytterbium ion trapped. And my colleague is now at the National Measurement Institute in Germany, in Brunswick, working on this project. And so in our timekeeping system, we use 3 cesium beam clocks as well as 1 active hydrogen maser, and we measure the time offsets at our clock in order to generate the real-time realization for the Thailand Standard Time. And we compare the time that we measure daily with the BIPM, while we insert the same signals from the same clocks that we use to generate the UTC NIMT. And each antenna, as you can see on my slide, it is 1 meter apart. So we observe the same satellite, and the signals are from the common clocks. So at the moment we have 3 receiver, and 2 of them can provide only Rhinix that can be convert for the timing comparison, but not for the real-time corrections. So now the calibration service that it was approved by the BIPM, I would like to highlight the local frequency standard of 5 megahertz and 10 megahertz. So at the moment, we can do our base measurement capabilities of 1 times 10 to the minus 13. And this can be calibrate those internal clocks of, for example, like rubidium frequency standard or cesium frequency standard. And the last one that I used to do it was for the remote frequency standard, and this was approved at the 2.1 times 10 to the minus 13. So this might be used for clock comparison of our GNSS receiver in the NCDC network. And the timestamp that we need to provide from our NCDC time server at the moment, they are linked to our NIMT time server to either time1.nimt.or.th until time 5, depend on how they would like to choose it. And in terms of other time dissemination, we did some common view where common satellites are observed at the same time in order to compare the receiver clock offsets. So this is a kind of pilot project that we did it with Royal Thai Survey Department. So thanked our team there. So we compare the time offsets of the time difference of the UTC that was measured compared to the GPS system time with UTC that measure at my institute with the GPS system time as well, and compare the time difference between 2 stations. And SBKK is at the Lat Pral, and if this is success, we might do more for all the GNSS receiver in the network. And if we need more precise timing, let's say better than 10 nanosecond, we might need to do what it's called by the BIPM, it's called the GNSS receiver calibration transfer, where all the delay within the GNSS receiver need to be measured and determined. So the next part that we would like to do on GNSS receiver calibration, so we need to understand the standard based on the ISO. So there are 3 standards that I put it on my slides. So maybe we need to check on this. The first one is on the GNSS receiver class. So we know what are the standards that we need to obtain at our institute, and the testing on network RTK measurements. And it's according to this ISO 17123 for the measurement system in the network real-time kinematic, as well as all those augmentation that is related to compute the positioning as well as the timing services. It was presented in the ISO as well. And one thing that we are quite agree with what they had done in the phase 1 is on the capacity buildings for all those surveyors, especially when they need to interpret their measurement results, especially on real time at their site, at their measurement sites. So the last part that we have at our institute, not only the timing measurements based on GNSS signals. We also have other measurements as well, like on absolute and relative gravity. And we produce like gravity mock, and we compare this with the international institutes of the metrology, and we have this 40-meter length calibration for those total station, as well as we are thinking of implementing the baseline for both total surveying station as well as a GNSS receiver. And we have those labs that we do the very precise angle measurements. So my conclusion today is, so we are the only official timing station in Thailand, and we provide the UTC NIMT, and we would like to strengthen the positioning and timing infrastructure, especially response to those critical infrastructure like power grid or telecommunication, where timing is important in those areas. And we would like to improve the PNT quality scheme by applying the national quality infrastructure, especially on standardization and testing, as well as capacity building. So we also have other geodetic measurement standards, and we have practiced the realization of those standards at our NIMT campus in Pathum Thani, Klong Ha. So please pay a visit of our facility at our site or the website that we have. So thank you very much for your kind attention.
Thank you very much, Dr. Thayatip, for emphasizing the importance of the timing. It's very critical information in case when we really need it, especially during this time period where we are using 5G in the telecommunication and even 6G in the future. We never know when we lost time what's gonna happen. I have my experience. My close friend almost got killed by his wife because he promised his wife to come home by midnight, but he is a little bit late. So timing is very critical, I would say. Okay, let's move to the final presentation. Let my co-chair introduce.
Next, we proudly present to you the video presentation of the 8 Tigers projects. And let's see how we work as one team. Please.
Okay, thank you, Chon Sensei. Thank you, Tsunatat-san. As Tsuji-san and Sonpok-san mentioned, Thai and Japanese companies performed 8 pilot projects in the field of survey. Okay, thank you. Construction, agriculture, and autonomous driving in Thailand. I would like to show you the result using videos prepared by the companies. The first one is a survey pilot project named Accuracy Verification from Network RTK and Static Survey, performed by Topcon Corporation, Topcon Positioning Asia in Thailand, and others. They built 6 survey points across Thailand. 3 were having the nearest coast station within 30 kilometers, and the other 3 were not having the nearest coast station within 30 kilometers. And they clarified how the differences in distance influence the result of survey. They found no big difference in terms of the accuracy, but stability of the network RTK is affected by density of coast stations surrounding survey points. Positioning stability was better when the distance between the survey points and course was closer. Okay, thank you. And the next one is a construction pilot project named Road Construction using ICT construction machineries, performed by Nishio Rent All and Topcon, both from Japan and Thailand. Thanks to a kind understanding and cooperation from Nippon Road and Thai Nippon Road, ICT construction using NCDC data was implemented at a construction site in Thailand. They conducted slope shaping, base grading, and paving work, and as a result, confirmed that ICT construction using NCDC data could reduce the initial cost of the work and shorten the work time. It was also found that safety could be improved because the manual work required in conventional construction could be reduced. Not yet. Not yet. Where is it? Okay. And then we had 5 pilot projects in agriculture field. One is named Smart Farm in BioHub EEC area, performed by BiomatLink, a Thai company. Their business is to take care of every process of producing cassava, from planting to harvesting and transportation. And for this project, they grew and harvested cassava, both with conventional methods and new methods using NCDC data, and compared work efficiency and productivity. The result was that using NCDC data and their products, they could plant, treat, and monitor cassava with high accuracy. And then they achieved double yields with half man-hours than the conventional method. The next is utilization of NCDC data in agriculture, performed by Quantum Motors, a Thai company. They compared the work efficiency, cost, and productivity of farming methods using agriculture drones with NCDC data, and sensors to monitor growth conditions with commonly practiced farming methods in rice farms in Thailand. For their pilot project, they flew 2 kinds of drones. One was for fertilizer application and pest control, and the other one was for monitoring the growth. And they confirmed that the use of agriculture drones and sensors using NCDC data can reduce costs, improve work efficiency, and at the same time increase yields. This is the one which did spraying. And this one was used for monitoring. And it took some images to monitor the growth of the rice. Yes, the next is development of precision spray method by using Yamaha unmanned helicopter, performed by Siam Yamaha Motor Robotics. They applied fertilizer using their unmanned agriculture helicopter and NCDC data in several farmlands in Thailand, and compared the result with a normal GNSS-only flight. As you can see, the helicopter flew smoothly using NCDC data. It was confirmed that while the conventional method can apply fertilizer 100 rai per day, using NCDC data can apply 150 rai per day, thereby improving productivity. It was also confirmed that using NCDC data contributed to improved safety by enabling highly accurate autonomous flight and reducing the pilot's workload. The next one is benefits of auto steering for rice production in Thailand, performed by Topcon Corporation, Topcon Positioning Asia in Thailand, and in cooperation with Thailand Rice Science Institute. Oh, sorry. Yes. Come on. Yes. The next one. Yes. They installed an auto steer to a rice transplanter and produced rice in TRSI's paddy field. They produced rice also with conventional method and compared productivity and work efficiency. Using auto steering and NCDC data, rice planting operations could be carried out with higher accuracy. In addition, the time required could be reduced by 25% compared to the conventional method because the operator was freed from the tractor steering work and could concentrate on other tasks in parallel with the rice planting work. These facts show the significance of the auto steering method using NCDC data in terms of productivity. Next is smart agriculture. Utilizing autonomous and telematics technology in Thailand, performed by Yanmar Agribusiness and Yanmar SP. They produce several crops using 4 models of autonomous agricultural machinery, 2 tractors, 1 rice transplanter, and 1 combine harvester with NCDC data in Thailand, and evaluated applicability and effectiveness of the introduction of smart farming technologies. They confirmed that significant labor saving can be achieved through cooperative work using a robot tractor and a straight line assist tractor together, resulting in 1.6 times increase in work efficiency. They also found that beginner operators can operate the straight line assist tractor alone at 1.4 times the speed of conventional work while maintaining the same level of accuracy as skilled operators. They also conducted hearings with agricultural workers and confirmed expected effects, such as reducing work burden and providing useful information using sensors and visualization systems for work management and planning. The last one is autonomous driving, intelligent driving vehicle in Thailand, performed by Asia Technology Industry, Tokai Clarion, Core Corporation, and Chulalongkorn University. They demonstrated their autonomous driving system named Yadokari iDrive with NCDC data and multi-GNSS satellite system. It was confirmed that the use of NCDC data enables autonomous driving of micro vehicles even under the conditions where satellite signal reception is not very good. They kindly invited project members and representatives from the 6 neighboring countries to take a test ride, and participants really enjoyed it. During their pilot project, they gave us a lot of useful and important feedback, and we tried to improve NCDC based on that. All of the project members appreciate their kind understanding and great support to the project. Thank you very much. 文化ありがとうございました。
Thank you very much. Now we come to the end of the session now. I think we have time for maybe 2 or 3 questions if you like. Please feel free to ask any question to all the speakers except for me. Because I'm not a speaker. Any questions? Please. If not, I would interpret that all the speaker make a very clear presentation and everyone understand it very well. So uh, right now I would like to close the session and please give your approach to all the speaker here. Thank you very much for all the attendance and all the speaker. So we will close the session here now and maybe you can join other session if there's still some. Yeah. Thank you very much.